We've been asked to identify at least 4 distinct polar coordinates and sketch the graph of r equals 2 cosine of 4 theta. Looking at this equation, I recognize it as a rose curve. Because the number multiplied to my angle theta here is even, I know I'm actually going to have twice that number of leaves. I'm going to use my graphing calculator to get started here. So I have 2 cosine of 4 theta here. And then I can watch it graph this out, and I see those 8 leaves, and I know they're all equal rotations of each other. So they're all 45-degree turns of each other, and it looks like the most natural angles for me to use are the quadrantal angles and then those multiples of pi fourths. And so I've been asked for at least 4 points. I'm actually going to choose to plot 8 points. And I'm going to choose those 45-degree angles. And, I might expect, if I didn't really pay attention to how my calculator just graphed that curve, I might guess, that I just get 2 every time, right? The end of each rose petal, 2 units out. But I'll actually see something interesting happen here as I plot these 8 different points. All right, so there's room for the points I'm going to plot. I can plug in a 0 and I'll get out a 2. When I plug in pi fourths, I get the cosine of pi there, which is actually a -1, so I get a -2. And so what I realize is that at 0, I'm here. At pi fourths, I would imagine being here, but that negative value for r says I'm going to plot this point down here. So it's like I traced out part of this leaf and then part of that one. And our calculators actually do plot the points in order, just very quickly. And so we see that it went through the origin and got that point down there next. Well, if we think about plugging in these angles, we're actually going to watch it alternate between 2's and -2's all the way through. And you can double check me on that. And so that's the end of each rose petal. If I look at my graph, this is certainly enough points. I see there's one more point we definitely go through, and that is the origin, and it wouldn't be too hard to find an angle theta where we get out a 0, or actually, of course, multiple points where we get out a 0. But for now, I think I'm just going to try to trace my rose curve. And I'm going to start by plotting those points that are highlighted in my table. And so just to make my job as easy as possible, I'm going to let this last circle be 2 units away from the origin. That way I don't have to count every time. And so at angle 0, I'm out here 2 units away. At pi fourths, I'd expect to be here, but that negative reflects me through the pole. And I just keep going around in that way. At pi halves, at 3 pi fourths, I get that -2, which reflects me through the pole. Pi, 5 pi fourths, 3 pi halves, and then finally 7 pi fourths. I know the origin is on my graph, and again, you can think of what angle you would actually plug in for theta to know that. And I leave that as a challenge to anyone watching the video. And now I'm just going to draw in my leaves. I'm not going to worry about drawing them in the right order because I want to focus on getting a good picture here. So this first leaf comes out, hits here. Of course, if I wanted to make my picture better, I would just plot more points. Of course, as I like to joke, I could also just let someone else draw it. That would usually make it a better picture too. All right, just drawing my 8 leaves. I'm not really worrying about the order in which these are happening. Looking at the graphing calculator screen, I know they should not overlap, so I'm trying not to have overlapping arcs here in the middle to draw my 8-leaved rose curve. All right, and I didn't graph them in the right order as the calculator would, or as if I plotted a whole lot of points through. But there is the graph of r equals 2 cosine of 4 theta, and that's it for now.